starting? Yeah, okay, right. So, I apologize for the venue. That was, they didn't even notify me. Anyway, so, in Computer Science 114, basically what you practiced with Prof. Heldenays was to program. Everything was about the programming, right? And so for those of you who came in from school who could already program, that might have not been as exciting as it could have been. So what we will do in this semester is to up the stakes a bit. I now assume that you can write assignments, ifs and whiles, you know all about recursion, you know all about methods, and we will now look at object-oriented programming. However, I really like theory. And I do believe that just using a thing is not the same as truly understanding a thing. So, I will expect you to write theory tests. In the theory tests, there will be no question, none whatsoever, which says, write a program to. I know you can program. Why should I test it? What I want to know is, do you understand what the hell you're doing when you program? Yes? So, therefore, I expect you to say, give the definition of, give an explanation of, compare the advantages and disadvantages versus method A and method B, and so on and so forth. Okay? So that is what you will get in this course for 1 month. After that, you will get another lecturer. See, we're grooming you for computer science too. So we took all the senior lecturers in the department, and each of us gets a month. So I'm doing the first 4 weeks. After that, you will get Professor van der Merwe. And he is an ex-mathematician. So he also likes theory as much as I do. But incidentally, he's an absolute pain when it comes to using Java correctly. So then you'll be forced to all the practical stuff that I sort of let flow a bit in the first month. You'll come back to that and say, you're supposed to know that in Java, right? And then just to let you pass the course, Prof. Heldenays will take over. Right? Okay. So after my sermon, let's get to logistics of the course. Are there any Afrikaans-speaking students, well, or English-speaking students as it may, or any other language-speaking students as it may, who would like interpretation from English to Afrikaans? Baie dankie. Please note that I am as Afrikaans as they come. Which means that some of my jokes will be totally, I don't know what, just not a joke in English. And I tend to say very strange things. Because I translate directly from Afrikaans. So if I do say something very weird, please frown and start laughing. And I'll think about it and say it in Afrikaans and let somebody translate it into English and so on. If anybody wants me to repeat something in Afrikaans, put up your hand. Okay? So, class rep. Who's the class rep? Five of us. You're not supposed to have 5, but anyway, I have to My yellow was my ball. You see this is so ridiculous. Oh, sorry. Let me get manual. Probably. Oh, here's old paper. Okay. Remember to call me back after the lecture. I don't even have paper. Somebody must give me a piece of clean paper. Yes. Okay. You contact me not by going to my office, because I'm almost never there, and when I'm there, I close the door and work on my research. So, not a good move. But 24/7, unless I'm sleeping, you can send me an email. I answer emails always. So I've got a problem. I know about it, I'm working on it, but to your advantage, at this stage in your lives, I answer emails anytime unless I'm asleep. LBZIJ, oh, that's something I see on Saturday. Well, you didn't see me that sick. So, Prof on sale, right? And this is the way to contact me. Okay, so if you have any question, Mr. Kasim, are you here? Yes, see me after the lecture, please. Anytime. However, I am not the yellow pages. Yes. So, if you want to ask something that you can find out for yourself, please do so first. Yes, like which room in the Panashtar building, my word. Look on my.sanda.ac.za and look at your timetables. It's there. Yes. So if you can find out first, please do that. If I get silly questions, I will send it on to the demi to answer, which will cause a delay in the answer. However, if you have a legitimate problem, I'm more than happy to talk to you. If you need to make an appointment with me to talk about something which you don't want to discuss over email, send me an email or come to me after class. What? What did I know to see? Send me an email to make an appointment. Right, so that's me. Class attendance and tutorials. For what it is worth, for what it's worth, I am YouTubing the lecture, right? But I forgot about it, so I didn't talk there, so I'm not sure how much you'll hear, but okay. So you will get a podcast of the lecture. They're all available on YouTube, same as in the first semester. Every person has a different way of learning. I absolutely find it ridiculous that people attend lectures and then do all their social stuff while sitting in front of me and irritating me, right? So it's up to you whether you want to attend the lecture. If you want, especially on a Friday morning, my word, especially on a Friday morning, you might consider opening your laptop and following the class from under your duvet. Yes, all the same to me. They pay me, I have to be here. Unless Marty's Wi-Fi falls over, the podcast will be there on YouTube. So just search for it, it's there. There are also a lot of slides. Slides are evil. Slides are from the dark side. Because, no, indeed they are. Because what students do, actually I have children who are currently undergraduates. I know exactly how students work. Some of the nerds are a bit otherwise, but anyway, mostly 90% of students read the slides quickly, think they've prepared, right? Because why should they read the book? But incidentally, it's very good for you to read the book, yes? So there are slides on the website which gives you flashy animations and pictures and whatever about the work. You're more than welcome to look at it. Doesn't bother me, same content as I'm doing in class. What I do, and I've done it for the past 2 years for my second years, and incidentally, they prefer that to any other method, given the way I ask my test questions. I use the document camera and I show the book. Yes. I have nice slides, I'm not lazy. I have nice slides and they're available. But if I work through the textbook in the lecture, you know what is important in the book and what is not. Yes? Which means that when you go to prepare for the test, you open your textbook, not the slides, your textbook. And when you read it, hopefully you remember what I said while showing the book. Okay? So this is the first thing that's odd. But all the other information is there on the web if you want to. I cannot guarantee the podcast. So if something goes wrong with Wi-Fi and the podcast breaks, then you just have to get notes from somebody else. Tutorials are not compulsory. If you work better on your own, if you're the kind of person who like to read, see a problem, like to solve it on your own, it's up to you whether you do those stats in the venue or at home. If you come to Narga on a Thursday afternoon and you are there and you've struggled with the TAT, then the demis are there to help you. And the tutors as well. We're continuing with the tutor program. So that is highly recommended for those of you who like to ask questions about things, right? If you're the kind of person who like to work on your own and you are more effective working through the work on your own, it's up to you whether you attend or not. However, there are compulsory assessments, all theory tests, all practical tests, and all project demonstrations. You are expected to be there in person. If you're not, you fail. That's it. Yes? Read the webpage about sickness, health, my extra violin lessons, whatever. My granny stubbed her toe and therefore I couldn't come. You know, that kind of nonsense. If you have a sporting event, I only honor official university sporting events. There will be, and you need to bring me a letter from the sports office saying that you're on an official university event. So just because you would like to do a fun run on the Friday morning when my test is scheduled, pity. Yeah, 0, you're out. Wat moet ek nou nog sê? Oh, yes. In the first semester, if I remember Prof. Geldenhuis correctly, for your projects, he gives you templates, right? Did he do it this year as well? He didn't. Wow, okay, my moaning started working. Okay, so you will have a combined project between myself and Prof. van der Merwe. The project's on the web. Everything is on the web already. But for the moment, only believe everything concerning the first 4 weeks. Yes? Because I don't know how far Prof. van der Merwe is with updating something. So for the first 4 weeks, all the details are correct. Also, so there's a project. We cannot fit in a project demo for this part 1, my part of the project. So you will demo your combined project with Prof. van der Merwe. Okay, so we will just mark it. Okay. 11th of August, Thursday the 11th of August, 2 o'clock to 5 o'clock. You are writing a theory test for me. If anybody is a repeater, you can't attend, you have to contact me. Okay? So that's your first theory test. And then Prof. Look, so what we could do is use your standard test time, you know, your middle semester test. But then you, like 3 weeks past my part of the work anyway. So it makes more sense to me that you write your first test while everything is fresh in your mind. Yeah? So on the 11th of August, Thursday afternoon, 2 to 5, you're writing your theory test for me. Okay? This theory test will cover section 3.1 to 3.3 in the textbook. And to prepare for that test, you read through the textbook, concentrating on definitions, examples. You do the Q&A after each section, and you start the simple exercises after each section. Yes. And you do that after each lecture. If you don't have time tonight, then you, at the latest, do it after each week. So I'm covering 3.1 this week, 3.2 next week, 3.3 the third week, but we have a happy South African holiday again because it's voting day. So we're missing a lecture. So then in week 4 on the Monday, I cover the last of 3.3. The Wednesday is revision, and the Thursday you write the test. Incidentally, your project also has to be in by week 4. Okay? The tutorials do not concern the project at all, so they are separate. So with the project, I am not handling your time management. Do not start the night before. It's fun, it's cool. So, yeah. No. Then again, if you do, it's up to you what marks you get. Plagiarism, you know the plagiarism thingy. We'll talk about that again in the text. That's about it as far as logistics are. Oh, the tutorials. I hand out tutorials and answers simultaneously. So for the first 4 weeks, there are tutorials. In fact, I put up a tutorial for week 4 when you're actually writing the test. So it would be good for you if you do that in your own time. The idea is that you learn something. Yes, and that the solutions act as scaffolding. So if you struggle, you first start with the TUT. You struggle a bit, you ask the demi, you have no clue what they're trying to say. Then you peep at the solution, but just the first 2 lines. Yes? Just quick look. You close the solution again and you work further on the TUT. Okay? The idea is simply that you learn something. Okay? The TUTs are again in Narga H and Narga D. Anybody who got 55% or less for Computer Science 114, I'd like you to go to Narcha H. It's a smaller room, so that's the tutor group. If Narcha D is then overflowing, we'll send a few more people that way. But we need a bigger room for the big crowd, right? Okay. Any questions? Yes.
CS144 website updated.
On SunLearn.
So is the project information available?
Okay. Yes.
Regarding tutoring, is it still or using guidelines for tutoring? Is it same as it was also?
Such as?
I mean, getting in contact with tutors for.
Oh, right.
Such as.
No, not. So during the first start, yes, the people who think they would like to be enrolled in a tutor group again, you're in Narcha H. There's only one remaining tutor from last semester, Jose Lambo, right? And then there are 2 new tutors. So then we will set up a tutor group and we'll make the information available about how to contact them and so on. Okay, so the idea is that the tutors work with you during the TUT period. But not necessarily just on the TUT, also on the project. More questions? No? Okay, let's go. What is a primitive type in Java? Give me an example of a primitive type in Java. Yes. No, but a good guess. Simpler than a string. Int, yes. An integer is an example of a primitive type. So, let's for a moment consider this whole object-oriented thing is actually fairly simple to explain, but sometimes you trick yourself when using it, or I ask definitions and so on. So we're going to figure out up to memory level how objects work. So in the beginning, of this year, let's not be philosophical. In the beginning of this year, when you started with Java, you started with types. You had integer, character, double, and so on. Boolean, yeah? Those are the primitive types. They are built into the Java programming language. And then you also used array and strings, and they're a bit more complicated, yeah? And although strings and arrays are not primitive types, we let you use them without explaining what the difference is. But typically when you do programming, what we want to do is to use abstractions, okay? So if you write a program about, if you write an Angry Bird implementation, you want to have a thing which you call a bird, and you want to write down bird jump, bird fly, bird dies, yes? Because that is the level of logic that you want to apply. At the moment, without the object orientation, you can think that way, but that is, then you have to write static methods and call it bird jump or something. And a bird is actually, you can't think about birds, you have to think about your representation of a bird in terms of arrays, strings, integers, booleans, and so forth. Right. So the whole object orientation is about designing your program in a more object-oriented way to put a level of abstraction on top of the code that you write. So I want to argue about the birds. I don't want to argue about integers. Yes? And that is what we're going to do. Now, up to now, you used static methods. You always had to write that silly little word static, public static void main. Yeah, static blah, 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 name of method. And what we are going to do now, if you work with object orientation, we are not going to use static methods anymore. So there's going to be a difference in our methods, and there's going to be a difference in our data, our variables. Now, any formal system, like arithmetic, say I want to do something with integers, I always have a data type. Say the whole numbers, the positive integers. This has nothing to do with Java, right? This is just math. If I work with the positive integers, I can apply operations to them. I can add them, I can multiply them. If the formal system is closed, that means if I apply an operation to the data, I get the data of the same type. For example, integers are closed under addition and multiplication. Yes, because if you give me any two integers, x and y, if I multiply them, I get another integer. However, integers are not closed under division, clearly. Because if you give me 3 and 4 and I divide them, I actually get a rational number, 3 upon 4. Yes? Okay. So what we're doing, what we want to do in Java, there's a lot of terminology that we'll have to pick up. So the first thing we're defining is a data type. What is a data type? A data type is a set of values and a set of operations defined on those values. Just like the integers, a set of values and a set of operations. Only we're going to do it in Java. Right. Okay. So the book is very gentle. To my mind, they're going on and on and on about it, but okay. So section 3.1 will show you examples of data types and how to use them. Only how to use them. They don't explain anything more, just how to use them. Section 3.2 will tell you how to make your own data types, how to create your own data types, and all the intricacies in Java about that. And then section 3.3 will talk about designing a program based on your own data types. Right? So immediately for your project, I assume all of you have read on the web what the project is. Woo! It's that traffic solving puzzle. Yes, you have a grid and you have different sized blocks in there and you have to maneuver out of it. For my part, for the next 3 weeks, you simply have to do the GUI. So draw it, the standard draw, and also check whether a board is valid or invalid when it's defined with the text. And then the month after that, you will write a solver. So if I give you a definition of this puzzle, you will write a Java program that lets that guy in the red car actually get out of the crowded parking lots. Okay? So now you have to start thinking. If I think about objects in a GUI, Is it even possible? What will my objects be? Yes, because you want to abstract the whole thing to my own data type. So clearly, car will be a data type. Parking space might be a data type. I'm just throwing it out here. Openings might be a type. Yes, or not. Yeah, right? So think about the objects. Immediately we think about this in a much higher way, because if you think about cars, you have to think of the size, the rectangle, where does the car start, where does the car end, and now you're in integers and coordinates, and it's a whole bloody bowl of spaghetti. But if you rather think about cars, and each car might have a size or coordinates, yeah, then you think on a higher level. Right. So definitions, you know what the data types are. Here you get the primitive data types. You don't, because this bloody thing just died on me. Why didn't you yell? But not here. Yippie! Wat? Go aan. Land? Nee, land is iets anders. Dis werk. This is so ridiculous. Okay, I'm just talking, right? Following your box. Now, I have a better plan. Dit wil ook nie werk nie. I couldn't switch over to my laptop earlier. And I can't, because then the broadcast stops. Right. So you'll excuse me if I have a wee peek at my book every now and again. I'm on page 316. Without the benefit of a bloody document. I can't believe this. I want a different room. Whatever. Follow in the book. 316. Yeah, page 316. We've got the normal primitive types. What is the... Guys, everybody calm down now. Ja, alles is goed. Alles is goed. Ja, maar dan maakt dat niet toe. Ek weet hoekom kan. Dit niks met die arme dokumentkamera te doen nie. Dit is die ding wat dood is. Maar ek dink hulle is al twee op dieselfde. Sy liggie het seker maar geplaas. Your bad luck. I hate this one. Okay. So I have primitive types. Those you started out, okay, ons nou weer terug. Yeah. Primitive types, integer, bool, those kinds of things, built into Java. What is a type that is not a primitive type? Is called a reference type. And we will have a look at how reference types, why it's called a reference type just now. Okay? So you have either a primitive type, those holding things into Java, except for char and Control-Delete, except for strings and arrays. Yes? Strings and arrays are reference types. If you do object-oriented programming, you also get reference types. Okay, so that's just the name. Okay. Okay, this is very weird. Okay. So the thing is, what you do with object-oriented programming is you define your own reference types. That's it. Like car, parking lot, parking space. Yes, that will then become a type in Java. So it will have a data value and it will have an operation on it. So car might have an operation turn, or car might have an operation move forward 5 steps. Yes? Okay. Basic definitions, again, data type is a set of values and a set of operations defined on that data type. Page 317. I find this particularly difficult. Okay, so please look in your textbooks on page 317. maak by Biophys. Hulle sluit alles toe. Okay. Page 317, there's an example about particles. How many of you are not doing BSc? Couple, not many. Okay. Particles is a theme. Yeah, it's good enough. But what's nice about this thingy is that it can exert a force, so there is a potential about how strong this force is. Okay, this is like serious handwriting, but it explains the problem. And this force, if I have a particle at a certain position, then that particle exerts a force. Okay, moenie my skiet. Enigiemand van julle wat teoretiese fisika doen, my skiet nie. There's a force, because there is a particle, there is a force. So if I'm a certain distance away from a particle, I can feel that potential over here. Okay, I won't use that example. If you're a seriously intelligent woman and you walk into a room, then all the guys feel the force. Gender correct. Okay. So, what the example does on page 318 in the textbook is we're going to define a data type called charge. And we are going to program with this data type called the charge. So instead of having int x, I'm going to have charge x. Yes? That objecty thingy that I do is my data type. So on, who does not have a textbook here? Oh my word. Okay, want ek het usually altyd the. Ek weet nie wat om vir jou te sê nie. Okay. Okay, right. I'll find out why this happened. But it's just the lamp. Okay. So I'm still trying to bumble my way, fuddle my way through this very weird lecture. Okay. Yay! Ons wil die computer weer sien, ons wil camera weer. All right. Okay. So I like my like a bit weird. I don't know how long it's going to last. Okay. So what I do, how do I do object-oriented programming in a nutshell? You know that you could have modules. That is what you did in chapter 2, where you have a lot of methods in one module, right? And those methods, the class, yes, is in a separate Java file. When we do the object-oriented programming, we do the same thing. So now we want to consider an object called charge and all the operations that can happen on it. Right, so we make a Java file called charge.java, and we have the public class, and then you can write all the methods that all the operations that you apply to this data type, you can put into that class, that file. Yes, that Java file. Now note how we define a charge. It's the position, and then, as explained previously in a very weird formula given there, I have a position x, y, and then a Q, and a K, and an R, and so on and so forth. In this case, we are looking at Q. So if I define an object, I must say where is it, x0, y0, and then what the Q value is. And then I can determine the potential at any other value xy. Okay? So please note the following. Charge.java, in my Java file, I have a public class charge. This thing over here is very strange because you see you don't have a return value. This charge is the same name as the class name, yes? And that is called a constructor, right? And that is used when we declare variables of this type. I'll show you an example just now. And then there's a method that I can use that acts on variables of type charge. And then there's another method called toString. All objects have this operation toString because it permits us to print values. So you will define how to print a value, how to change the values in an object to a string so that you can print it. And for example, suppose it's a date. Yes, so you have a day and a month and a year. So you want to change that into a string so that you can print date as an object. Right? Okay. So what we're going to do now is simply, how do I use this? My word, 4 minutes. I wasted a bit of time, so I'm going to run through this. If I make an object, I can declare an object with that type. So I make a new data type charge, I can declare an object, and the important thing is what happens when I do that. What happens when I do that, look at this example. I declare a variable C1 as type charge. What happens in memory? And you have to be able to draw this in a test. I get a variable name block in memory, just as you did for primitive types. And that reference, for the moment, will be empty. Then I do the following. This is the declaration, and this is the creation. Yes, this is the construction. This is where you do it. You say that variable is new charge and give values. So it's a bit like arrays. Yes, because remember that with arrays, we also did it that way. And with strings, you also had that new keyword there. Now, what does new do? I know that the variable of type charge is called C1. So I get a block C1 in memory. I get an open block over here. In the beginning, that 459 is not there. Not after I executed that. Then I use new. The moment I use new, I get enough space in memory to store the charge object, and I get the reference in C1 filled to point to 459. Yes. So C is an instance of that object. I can have many of them. And now I ran out of time. I would like you to read up to page 329 for Wednesday. I will give a quick overview, but not in detail. All right? I'll see you again on Wednesday. Thank you very much.